All right, let's talk about reversing the words in a string. This is one of those classic interview questions you're almost guaranteed to see. And, it looks pretty simple at first, right? But what's really cool is that the best solution reveals this really elegant way of thinking that'll help you crack a whole bunch of other problems too. So here's the plan. First, we'll break down what the real challenge is here. Then we'll look at the easy way out, the library method. After that, we'll get into the fun stuff, a super clever reversal trick. We'll see how to actually code it, and then, most importantly, why this little trick is such a big deal. Okay, section 1, the string reversal challenge. And yeah, it's more than meets the eye. Before we write a single line of code, we have to be crystal clear on what's being asked. Because, the devil's always in the details. And trust me, interviewers just love hiding tricky little edge cases right in plain sight. So, how would you reverse the words in this string? I mean, on the surface, it's easy. The sky is blue just becomes blue is sky the. Simple enough, right? But what if the string they give you isn't so clean? What if it's kind of messy? Yeah, look at that. You've got spaces at the beginning, spaces at the end, and even a bunch of extra spaces squished in the middle. This is the real problem. It's not just about reversing, it's about handling all this messy white space. A good solution needs to clean this all up perfectly. So let's be super clear on the official rules of the game. We're given a string, and we need to reverse the order of the words. But, and this is the key part, the final output has to have only a single space between words and absolutely no spaces at the beginning or end. We're basically transforming that messy input into a perfectly clean reverse string. All right, approach 1, the library method. This is the fast and functional way. Let's start here with the most straightforward approach. The one that just uses the awesome built-in tools that pretty much every programming language gives you right out of the box. It's a really clean 4-step process. First up, you trim it. Just chop off any white space from the beginning and the end. Then you split the string into an array of words. And the cool thing is that the split function usually handles those multiple spaces for you. Step 3, you just reverse that array. Easy enough. And finally, you join all those words back together into a brand new string using a single space. Done. Okay, so what's the cost of this method? Well, for time complexity, it's O of n. I mean, that makes sense, right? You have to look at every character at least once. But here's the kicker. The space complexity is also O of n. And why is that? Well, because we're creating a whole new array to store the words, and then another new string at the very end. We're using up extra memory, and that's a really important detail to remember. Okay, moving on to approach 2, the reversal trick. Now, this is the one that really impresses interviewers. This is the approach that shows you're not just a coder, but you're a problem solver. You're thinking like a pro. So you give them the library solution, and they'll probably nod and say something like this. Great, now can you do it without using split or join? This is the classic follow-up question. They're testing you. They want to see if you can build it from scratch, if you understand what's happening under the hood. And this is where our little trick comes in. All right, here's the secret. The first step is to reverse the entire string. Yeah, I know, it sounds totally backward, right? Why would we do that? It seems like it would just make a bigger mess. But just stick with me here. Watch what happens when we do. So the sky is blue becomes Ulbc-esque eft. Total nonsense, right? But wait, look closer. The words are in the right spot. We've got Ulb, which is blue, then C, which is, and so on. The word order is perfect. They're just spelled backward. We're halfway there. So now for the second part of the trick, we just go through this jumbled string and reverse each individual word. And like magic, Ulbc-isgi-at becomes blue is sky the. Bam! They all just snap right back into place. How cool is that? It's this beautiful 2-step reverse that gets the job done. Okay, so implementing the trick. This is where the rubber meets the road. The idea is awesome, but how do we actually write the code for this reverse and then reverse again thing, especially since we still have to worry about all those extra spaces? It really comes down to 3 main steps. Step 1 is to clean the spaces. And honestly, this is the trickiest part of the whole implementation. Once you've got a clean string, step 2, reverse all, and step 3, reverse words, are just the logic we already talked about. So how do we clean up those spaces manually? Well, you just walk through the original string 1 character at a time. If you see a character that's not a space, you just add it to your new clean string, no problem. But if you see a space, you have to follow one simple rule.
You only add it if the last thing you added wasn't also a space. That's it. That little rule magically gets rid of all the leading, trailing, and extra middle spaces.
Now, here's a really important technical point, especially for languages like Java. Strings are immutable, which is a fancy way of saying you can't actually change them once they're created. So to do all this building and reversing efficiently, you need to use something else, something changeable. A string builder is the perfect tool for this job.
All right, Section 5, why this trick matters. So we've got two solutions on the table, right? The quick and easy library method and this more complex, clever reversal trick. So why bother learning the hard one? What's the big picture takeaway here?
Let's put them side by side. Approach 1, the library method. Super simple, quick to write, it shows you know the language's tools. That's good. But approach 2, the reversal trick? Yeah, it's more complex, but it's space efficient and it shows a way deeper understanding. It proves you get algorithms. Think of it like this. The first one shows you know how to use a hammer. The second one shows you know how to forge the hammer. That's a completely different level of skill. And let's look at the complexity again. Time is O of n for both, no big difference there. But look at the space. The library method is always going to be O of n. But our reversal trick? Well, in some languages where you can change the string directly, it can be O of 1, constant space. That is a huge, huge win. Now, that little asterisk is important. In languages like Java, where you need that string builder, you're still using O of n space. But it's the potential for O of 1 and the algorithmic thinking behind it that really counts. And this really gets to the heart of it. This isn't just about solving one little problem. What we've really been talking about is a powerful pattern. The reverse-reverse idea is a tool, a new weapon you can add to your mental arsenal for tackling all sorts of problems. So I'll leave you with this question to chew on. What other problems could this reverse-reverse pattern solve? Think about things like rotating an array or other tricky string puzzles. Once you start looking for it, you'll see this pattern pop up all over the place. Thanks for watching The Explainer.